Jain students, today we'll continue with the lecture 4 for your chapter 1, that is real numbers. So today we'll be discussing, like HCF we've already discussed how to find by the help of Euclid's division lemma, and now we'll be discussing how to find HCF and LCM both by prime factorization method. I hope all of you know what is prime factorization, you all have studied this in your basic classes. When we represent or factorize a number in terms of their prime factors. Like just a quick recall of what is prime factorization. Suppose I have, let's say, any number. Let's say I have 102. So I will choose the lowest prime factor possible. Since I can see 2 here, it is an even number, so it is divisible by 2. So on dividing by 2, I get 51. Now since 51 is not divisible by 2, we'll try 3. If not 3, then we'll try 5, then 7, accordingly as per the number. So now if I divide 51 by 3, I get 17. And since 17 itself is a prime number, we do not have any other factor. So 17 simply requires 17 and we'll get 1. So the moment you get 1, your prime factorization is complete. So this is how we do prime factorization. I will take one more example for your ease. Let's say I take 273. Since it is an odd number because it has 3 at the end, so it cannot be factorized by 2. So after 2, the least prime number we have after 2 is 3. So by 3, if I factorize it, if I divide 273 by 3, I get 91 as a quotient. Now 91, so like it is not divisible by 3, not divisible by 5 either, but it is divisible by 7. So we'll go for 7. So when I divide it by 7, it goes 13 times. Again 13 is a prime number, so we need 13, that is 1. We'll take one more simpler case, let's say 176. So if I divide it by 2, I get 88. Again if I divide it by 2, I get 44. Once more, I'll get 22. Again by 2, I'm going to get 11. Now since 11 is a prime number, so now for a prime, we need the same prime number. So this is how we do prime factorization. Now the point is how to find HCF and LCM of 2 or more numbers. So let's see. So we'll start with that. Okay, so straight away I'll start with a question. Let's say you have to find, first question, let's say you have to find the HCF and LCM by prime factorization method. If I take the first number, first case as 90 and 144. So first of all, the first step that you need to do is we need to prime factorize both the numbers 90 and 144. So first I am going to prime factorize 90. Clearly 90 is an even number, so divided by 2, you got 45. So now 45 divided by 3, you got 15. Again divided by 3, you got 5. Again by 5, you got 1. Now, some of you might get confused. Just when you see this 45, you think of 5. That's completely fine. Your number may be in a different sequence, but the numbers will always be same. Like what I'm trying to say is, suppose instead of this 3, you might have thought of 5. Then it's completely fine. Your prime factorization is completely correct. No issue. So when you divide 45 by 9, you get 45 by 5, you get 9. So again 3 and 3. So your sequence may be different, but the terms are always the same. So either you do this way, that's completely fine. Now I will take the other number, that is 144. So now again divided by 2, I get 36. Again divided by 2, I get 18. Again divided by 2, I get 9. Now since 9 is an odd number, it is not divisible by 2. So I need 3, and 3 goes by 1 time. Okay, so now there is a way of writing these factors. the same way which you use in polynomials or in the terms of their degree. So 2 is just one time for this case. So I'll be writing 2 to the power 1 into 3 is twice. So 3 into 3, that is twice, means 3 square. 5 is also one time. So 5 to the power 1. Now have a look at here. So how many times you have 2 here? 1, 2, 3 and 4. So 4 times 2 gives you 2 to the power 4 into 2 times 3 give you 3 square. So now since we are done with prime factorization now, what we need to think of now is how to find the HCF. So your HCF simply contains common terms in all the numbers. In all the numbers means all the numbers for which you are finding the HCF or LCM. So common terms in all the numbers with their minimum power or degree, what do you call it? Okay, so HCF, what kind of terms you have to choose for HCF? Common term in all the numbers with their minimum power or degree. In all the numbers means in numbers for which you are finding the HCF and LCM. Here we have 90 and 144. So just think of the common terms. So what are the common terms? 2 is common. So common is 2, but the minimum power, common terms with their minimum power. Since 4 is less than 1, so 1 is the minimum power of 2. So HCF will be 2 to the power 1. Okay, do I have anything other common? Yes, I have 3 also common. And what is the minimum power of 3? Since both the powers are 2 only, so you can take 3 square. Suppose in case I don't have anything common between them, then I am going to take the HCF as 1. If nothing is common, nothing, not even a single term. But here we have 2 terms common, 2 and 3. So taking 2 with its minimum power, that is 1. Taking 3 with its minimum power, that is 3 square, that is same for both. So now the HCF becomes 2 into 9, and that is 18. 9 is 3 square is 9. So it becomes 18. Now comes the LCM. LCM means all the terms with their maximum power. All the terms, whether it is common, uncommon, you have to consider all the terms with their maximum powers. We will not take off or think of only the common terms. If we have that term even once also, we have to take care of that single term with its maximum power. Now the approach changes a little for LCM. Now, so all the numbers, so we'll be including all, means all available factors, that is 2, 3 and 5. Here also you have 2 and 3. So let's compare 2 first. So 2 we have one term here and one term here. So what is the maximum power? 4. So we are going to take 2 to the power 4. Now consider 3. 3 here also and here also. What is the maximum power of 3? 3 square. Now 5. 5 is here. It does not matter whether 5 is here or there. If I have 5 at least once also in any of the term, I have to consider 5 with its maximum power. So now 5, what is the maximum power of 5? 1. So 5 into 1. So your LCM will be 2 to the power 4 is 16 into 9 into 5. Solve it, you are going to get the answer. So this is how you are going to find HCF and LCM. Don't worry, in case you are not very quite confident out of this question, we'll do more problems. So you don't need to worry. So I hope this is clear. We'll come up with the next problem now. Okay, now some of you might be a little confused regarding like how to choose term in case of LCM or LCM. I'll take some example, some random example. Suppose you have two numbers whose prime factorization is something like this. and the other number is, let's say, this is just an example. I have taken some random prime factorization for any two such numbers. What you need to find out these two prime factorization is HCF and LCM. This is just a random example. There might not be any specific number, but I've just taken simply a prime factorization of any two numbers like this. So to find HCF, I know what is HCF. We have to choose common factors with their minimum power. So do I have 2 common here? No. Do I have 5 common here? No. Do I have 7 common? No. Do I have 11 common? No. But I have 3 common. So 3 is the common factor. But for HCF, we have to choose the common factor with their minimum power. So what is the minimum power? Like here it is 3 to the power 1, here it is 3 square. So that is 3 to the power 1, that is 3. Now LCM. LCM, you have to choose all the factors with their maximum power. Now I'll start from this side. 2. What is the maximum power of 2? Available power 1. That is 2 to the power 1 into. What is the maximum available power for 3? So 2 is done. 3 is also done now. Maximum available power for 3 is square. 3 square. Maximum available power for 5. Since there is no other term for 5, the maximum power is 1. That is 5 to the power 1 into. Maximum available power, 3 is already done. 5 is done. So maximum available power for 7 now is 7 square. And maximum available power for 11 is 1. That is 11 to the power 1. So you have ultimately 3 square is 9 and 7 square is 49 and 11 to the power 1 is 11. Simply solve this, you are going to get your LCM. Now suppose you have, now let's take one more example. Now suppose you have prime factorization for two numbers as 2 into 3 into 7 and 5 into 13. So what will be the HCF? Since we don't have any common term, 2 is not common, 3 is not common, 7 is not common, 5 is not common, 13 is not common. Since we have no common terms, we will take HCF as 1. Now to find LCM, you have to consider all the factors with their maximum power. So 2 with, what is the maximum power for 2? 1. So 2, 3, 7, the maximum power is 1 for all. So we will be considering all. Multiply this, you are going to get your LCM. So now we'll move to the other problem now. Okay, now I'll do it for 3 numbers now. Let's choose 3 numbers. Let's say I have 136, 170 and 255. Suppose I have 3 numbers. So the first step which I am going to do is I am going to prime factorize all the 3 numbers. So let's start with that. So first 136. So when you do it by 2, you have 68. Now again by 2 you have 34. Again by 2 you have 17. And since 17 is a prime number, you need one more 17 for it. And now the other number 170. So when divided by 2, it goes 85 times. Now it will not be divided by 2. Now it needs 5. So when divided by 5, it goes 17 times. Now again 17. So 1. Now the third number. Since it is an odd number, we cannot divide that by 2. Let's check for 3. So yes, it is divisible by 3. It goes 85 times. Now, again, if you divide it by 5, you are going to get 17. So, 1 more 17 and you get 1 now. So, this is the prime factorization for all the 3 numbers. Now, let's write the factors in the way which we used to write. Here you have 2 3 times, thrice. 2 is available, thrice. So, 2 to the power 3 into 17 is just 1 time, so 17 to the power 1. Here you have Nothing is repeated, so 2 to the power 1 into 5 to the power 1 into 17 to the power 1. Since here also nothing is repeated, so 3 to the power 1 into 5 to the power 1 into 17 to the power 1. Now, let's find the HCF. So HCF, the common in all the given numbers. So which is the term which is common in all the given numbers? The common term with its minimum power. So here the common term is 17, which is common for all, and its minimum power is 1. So the HCF is 17. Now let's find the LCM. So LCM, you have to choose all the factors with their maximum power. So let's start from here. 2 I have here and here, and the maximum out of this is 3. That is 2 to the power 3 into 17 I have here, here and here. That is same for all, that is maximum power is 1. Now I'll choose 5. 5 is available here also and here also, and the maximum power is 1. So 5 to the power 1 into 3. 3, the available power is 1. So simply multiply this, 8 into 17 into 5 into 3. Multiply this, you are going to get the LCM. So this is the process we are going to keep for finding HCF and LCM by a prime factorization method. We'll do one last problem for this, and I hope you're done. You won't be facing any problem regarding this. So one more problem for this. Okay, so the last problem for this, which I'm going to take 3 numbers. So the numbers are 441, 567 and 693. Let's find the HCF and the LCM. So first of all, what we need to do is we need to prime factorize all the numbers. So we start with 441. Clearly it has 1 at the end, so it is an odd number, so 2 will not be applicable here. Let's think of 3. So it is divisible by 3. How many times? 1, 4 and 7. Now one more time we will be dividing it by 3. So it goes 4 times and 9 times. Clearly 49 is the square of 7. So it is done. Now we'll choose the next number, that is 567. Again it has 7 at the end, so it is an odd number. So we can't use 2. So what we need is 3. Let's check whether it is divisible by 3 or not. So if I divide it by 3, I'm going to get 1 time, 8 time and 9 time. That is 189. Now again dividing it by 3, I get 63. Now again dividing it by 3, I get 21. Now again by 3, I get 7, and now 7 at the end also. Now I need the last number, that is 693. Clearly it has 3 at the end, so it is divisible by 3. Now it is not like every number which has 3 at the end will be divisible by 3. 83 seems to be divisible, but it is not. 83 is a number which has 3 at the end, but it is not divisible by 3. So now, but here it is divisible. The case is different because 6 is also divisible, 9 is also divisible, and 3 itself is there. So here you are going to get 2, 3 and 1. So now again it is divisible by 3. That is 7. You have 21, 2 left. Now again 77. Now 7 goes 11 times and I have 1. So we are done with the prime factorization for all the 3 numbers. Now I write it the way we used to, like 3 is available twice. So you have 3 square into 7 square, because 7 is also available twice. Here you have 3 to the power 4 into 7, and here you have 3 is twice. So 3 square, 7 is just 1 time, and 11 is like just 1 time, so 11 to the power 1. And now to find the HCF, what we need to do is we have to choose common factors with their least power or the minimum power. So here 3 is common, clearly 3 is here also, and here also. So what is the minimum power? Here we have 4, here we have 2, and there also we have 2. So the minimum power is 3 square. Do we have anything else that is common? Yes, we do have. What is that? 7. Now 7. Okay. So what is the minimum available power of 7? Here is 7 square, 7 to the power 1 and 7 to the power 1. So the minimum available power is 7 to the power 1. So when I solve this, 3 square is 9 and into 7 will give me, 63. So the HCF of the three numbers is 63. Now let's find the LCM. LCM, we have the same basic rule. We have to take all the multiples with their maximum power. Let's take 3 first. 3 I have here also, and here also. What is the maximum available power? Here we have square to the power 4 and square. So the maximum available power is 3 to the power 4. Now 7, the maximum power available is 1, 1 and 2. So this 2, that is 7 square is the maximum power available. Now what else is left is 11, and 11 has a power of 1. So 3 to the power 4 gives you, 3 square gives you 9, 3s are 27, 3s are 81. Into 7 square is 49 into 11. Solve this, you are going to get your LCM. So this is how we are going to do prime factorization, like how to find HCF and LCM by prime factorization method. I hope it is now clear to you because it has a very simple funda. That is, HCF simply means, I hope you remember, common factors, only the common factors with their minimum power. And LCM simply means all the factors with their maximum power. I hope you understood this well. With this, wish you all the best. Thank you.